Alright, so this video is going to complete the review packet that starts with all the trigonometric functionalities. And so first, what you should be able to remember are the values, okay, of all those special angles found on the unit circle. So for 30 degrees, I just want to show, go over, if you don't have them memorized, you can find them really quickly. Okay, so if we had 30 degrees here as our reference angle, right? What we could do is we could drop a vertical line and create a right triangle there. And so this little angle is 30, this one's 90, and therefore this one is 60. Remember that the side opposite 30 is always a 1. The side opposite the 60 is always rad 3, and the hypotenuse is 2 here for our special triangle. So then what we know is that sine of 30, sine is always the opposite over the hypotenuse side. So for the 30 degree angle, we put the opposite over the hypotenuse, and we get the value of 1/2, right? Cosine of 30 would be the adjacent side over the hypotenuse. So for this triangle, the adjacent side of 30 degrees is rad 3, the hypotenuse is 2, and so we would get rad 3 over 2, right? So they are really easy to determine using right special triangles, okay? So similarly for 60 degrees, let's open an angle out 60 degrees. Okay, and drop a vertical line again. So the bottom angle is 60 and the top one is 30, right? But the side opposite 30 is always the 1. The side opposite the 60 is always rad 3, and the hypotenuse is always 2. So if we had sine of 60, sine is still opposite over hypotenuse. So for the 60 degree angle, the opposite is rad 3 and the hypotenuse is 2, right? And then cosine of 60, cosine is still adjacent over hypotenuse, so the adjacent side of 60 degrees would be 1, the hypotenuse 2, right? So we get the sine and cosine value for 30 and 60. Now 45 is a different special triangle, right? Because we have 45, 45, 90. So remember the sides are 1, 1, and rad 2. Okay. So sine of 45, the opposite over the hypotenuse would be 1 over rad 2. Cosine of 45 is adjacent over hypotenuse, which is also 1 over rad 2. Right? So make sure you can remember those special angles there in quadrant 1, because if you can remember those, you can apply them to quadrants 2, 3, and 4 really easily. All right. So let's find some exact values without using a calculator. All right. First, what's cosine of 420 degrees? Right. Well, where is 420 degrees? We're going to start at 0, and we're going to rotate 360 degrees. And then we're going to go another 60 degrees, right, from there. So here's our triangle. So here's 60, right, and we already did cosine of 60 above, right? Cosine of 60 was 1/2, right? So we're going to get 1/2 there, the exact value, right? What's tan of 15 pi? Well, first, where is 15 pi? Okay, so we're going to kind of start at 0 and rotate, and every rotation is 2 pi. So 2 pi, 4 pi, 6, this is ridiculous, 8, 10, 12, all right, I'm almost there, 14, and then one more pi, which is going to put us at the same mark as pi, okay? So the point on the unit circle, this is a quadrantal, right? So the point on the unit circle is -1, 0. So tangent is sine of 15 pi over cosine of 15 pi. And sine of 15 pi is the y-coordinate. Cosine of 15 pi is the x-coordinate, and so we get a final answer of 0 there. Okay, so don't let this hypnotize you. That was a little bit ridiculous, but we can, you get the point. All right. So next, right, is evaluating inverse trig functions. So remember, this is where you need to draw those special triangles in the correct quadrant, right? So we have sine inverse of negative rad 3 over 2. Remember, sine inverse is restricted to 1 and 4, right? We're going to draw the triangle in quadrant 1 if the ratio is positive, and we're going to draw the triangle in quadrant 4 when the ratio is negative. So I'm going to draw a special triangle down here in quadrant 4. Okay? And sine is opposite over hypotenuse. So the top number is the opposite, the bottom number is the hypotenuse. So here's the angle I'm looking for right here. Right? I know the opposite side is negative rad 3, and the hypotenuse is 2, which makes the remaining leg 1, right? And so the signs kind of work out. We're over 1, down rad 3. Okay. What angle is opposite rad 3? Always, right? It's going to be 60 degrees here, right? But the answer isn't 60 degrees. The answer is when rotated from 0. So when we rotate from 0, we're rotating clockwise. So we need to make sure we write this answer as negative 60, right? So let's do one more. Let's do cosine inverse of negative rad 3 over 2, right? So you have to remember cosine is restricted to different quadrants. Cosine was restricted to quadrants 1 and 2, right? So we're going to draw the triangle in quadrant 1 if it's positive. We're going to draw the triangle in quadrant 2 when it's negative. So this one is going to get drawn in quadrant 2. There's my special triangle. There's the angle I'm looking for, right? Cosine is adjacent over hypotenuse. So I know the adjacent side is negative rad 3 and the hypotenuse is 2. So now the opposite side, okay, is 1, right? And the sign should make sense. We're going to the left, negative rad 3, up 1, okay, hypotenuse always positive. So what angle is this, right? What angle is always opposite the 1, right? It's 30 degrees, okay? But the answer is not 30. The answer is when rotated from 0. So we're going to take the shortest distance over there. And so if we were to rotate from 0 all but 30 degrees, we get an answer of 150 degrees. All right, so cosine inverse of negative rad 3 over 2 is 150. All right, so make sure you practice evaluating those inverse trig functions. All right, so let's do a nested inverse trig function. All right, what if we had secant a sine inverse of negative 1/2? Okay, work inside out. Right, work this first, and then worry about the outside function. So what's sine inverse of negative 1/2? Well, draw your triangle. Okay, sine is quadrant 1 or quadrant 4. So since this ratio is negative, we're going to draw our triangle in quadrant 4. Sine is opposite over hypotenuse, so the opposite side and the hypotenuse. Okay, here's the angle I'm looking for. All right, which makes the adjacent side rad 3. Okay. Now, we know x is 30 or negative 30. Okay, I know the answer in here. But if I were just to call this x, the answer is what's secant of that angle. Okay, so what is secant of this angle x, right? So let's just transfer this, okay, to secant x, right? So secant is the reciprocal of cosine. So we're going to do the hypotenuse over the adjacent side. So using the same triangle, put the hypotenuse over the adjacent side, and you get 2 over rad 3. All right, this is the answer. Okay, so the inverse trig function gives you the triangle and the angle, and then you want to do secant of that angle for your final answer. All right, let's do this one. Cosecant of tan inverse of 1/2, right? Tan inverse was also restricted to 1 and 4, just like sine, right? Cosine is the only one that's different here. So we're going to draw our triangle in quadrant 1 when the ratio is positive. We're going to draw the triangle in quadrant 4 when the ratio is negative. So this triangle is going to get drawn in quadrant 1. Okay, here's my angle x that I'm looking for. Now, the ratio for tangent, opposite over adjacent. So the opposite side is going to be 1, and the adjacent side is going to be 2. Right? This is not a special triangle. Right? This is not a 1, 2, rad 3 or 1, 1, rad 2, because the 2 has to be the hypotenuse. So how do we find this length? Okay, since we have a right triangle, we can just use Pythagorean's theorem, right? 1 squared plus 2 squared is the hypotenuse c squared. So 4 plus 1 is 5, right? So the hypotenuse is rad 5, right? So since this is not a special triangle, we actually don't know what the value of x is without plugging it into our calculator. But we don't need to know what x is. What we need to know is what cosecant of x is, right? And since we have all of our sides labeled, we can find cosecant of x. So cosecant is the reciprocal of sine. So we're looking for the hypotenuse over the opposite side here. So hypotenuse over opposite gives us rad 5 over 1, or just simply rad 5. Okay, so make sure you can draw those triangles and label the ratios to evaluate these nested inverse trig functions. All right, solving a trig equation. Okay, so you can find all the solutions between 0 and 360. You can list solutions. You can find a general formula for all the solutions. Chances are it's going to be a general formula type question. All right, so let's solve this one. Okay, first I got lots of things going on in this argument. Okay, so I'm just going to let x equal that argument for a moment. Okay, and I have pi over 18, which is really, really strange. But if you think of pi as 180, this is really just 10 degrees, okay? Because 180 divided by 18 is 10. So if you wanted to change this to degrees, we could do 3 theta minus 10 degrees if that's easier to look at, all right? But by making that substitution, now I know I want to solve this equation, right? Where does sine x equal 1? Well, sine is only 1 once in its fundamental period, right? Sine on the unit circle is the y-coordinate, and the y-coordinate is 1 at the top, right? So the only time sine is 1 is here, which is pi over 2 or 180 degrees, right? I'm sorry, not 180. How about 90 degrees? Okay, so depending on whether you want to solve this in radians or degrees, all right, there's your 2 solutions. I'm going to solve it in degrees, okay? So I know that x is 90 degrees, all right? So if I were to write the solution, oh my goodness, where's my head at? I would say x equals 90 plus 360k, right? Because it's going to occur every 360 degrees. We're going to start at 90, and we can rotate all the way around as many times as we need, right? But we don't want to know the solution for x. We want to know the solution for theta, right? So what I'm going to do now is I'm going to substitute 3 theta minus 10 degrees in for x. So I have 3 theta minus 10 degrees equals 90 plus 360k, right? So now what I need to do is solve this equation for theta. So I'm going to add 10, okay, to both sides, once on each side to keep this equal. So I'm going to get 3 theta equals 100 plus 360k. And then to solve for theta, I need to divide by 3 Now when we divide by 3, we got to make sure we divide everything by 3. So I get theta equals basically 33.3 plus 120k. Right? There is a formula for all the solutions. So we're just going to go 33 degrees, okay, and add 120 to it to get all the other ones. All right. So make an x, substitution. Find your general formula for x, and then substitute your substitution back in there and solve it for theta. All right. So let's do the same thing here for tan theta over 2 equals rad 3. All right. Let's let x equal theta over 2. Okay. So what I'm going to do is I'm going to solve this equation. Right. Where does tan x equal rad 3? Right. For what angle? So we can tan inverse this. We could use special triangles also. But let me tan inverse this. Okay. I want to make sure I'm in degree mode here. So tan inverse of square root of 3 gives 60 degrees. All right. X equals 60 degrees. All right. Is that the only time? Okay, tangent equals rad 3. So tangent's positive here. Okay, at 60 degrees. All students take calculus. It's also positive here at 60 degrees. So we have another solution at 240 degrees. But remember the period of tangent, right? Tangent repeats every 180 degrees. So we actually only need the solutions in quadrants 1 and 2, right? So if I were to write the general formula, I would add 180k here. Because tangent is pi periodic, right? It repeats every 180 degrees. So notice we are going to get that 240. If I let k equal 1, 180 plus 60 is 240. So I am getting this solution when I write this general formula, right? So this is within the first 180 degrees, it's only going to equal positive rad 3 once, right? So here's my general formula for x, but we don't want the general formula for x, we want it for theta. So I'm going to make that substitution back. All right, let x equal theta over 2. So if I solve this for theta, I'm going to multiply by 2, which means I need to remember to distribute here. And so I get theta equals 120 plus 360k. All right. Oops, you can't see that. So there I have all the general formula for theta. All right. So make sure you can solve those trigonometric equations. All right. So, that's kind of all I have on that review packet. All right. But I do want to remind you, we did cover law of sines and law of cosines. And I know there is one question over law of sines and law of cosines. We also covered vectors, polar coordinates, conic sections, and limits. And I know that there are questions on each of those topics on the final. So these ones shouldn't be too bad. It's one triangle. Okay, find the remaining side or find the labeled side using either law of sines or law of cosines. Not too bad here. Okay, vectors, you're adding, subtracting, multiplying, dividing, or finding the angle between two vectors. All right. The polar coordinates, you're going to be plotting polar coordinates and writing those polar coordinates in rectangular coordinates. So make sure you can do that. The conic section questions are just identifying which conic section it is. All right, so I'm going to give you an equation, and you're going to state whether it's a circle, an ellipse, hyperbola, or a parabola. All right, so make sure you can do that. All right, look at that chapter 10 video. It has some good examples at the end. All right, and then there is 1 or 2, maybe 3 limit questions on there as well. All right, so don't forget to study this last portion of the semester. But this is the most recent exam, right? So I didn't put that on the review. All right, so good luck studying, you guys.